Good evening, everyone. So, in the previous session, I started dynamic programming, and I explained some 3 to 4 programs from dynamic programming. So that is Fibonacci series and climbing states. Next to that, I given task as min cost for climbing states. Okay. After that, I explained the longest common subsequence program that is from strings. Okay. So yesterday I said that for making comparisons on the string, so or else for making some insertion, deletion, updation operations onto the strings. We prefer dynamic programming approach. Okay. So today we are going to discuss one more program. So based on that, okay. And after that, today's session we are going to discuss two more important coding section and interview programs. Okay. So zero one knapsack and next of all coin change. Already those programs you observed in greedy approach. Okay. So how the problem statement changed. Okay. So why we need to apply the dynamic programming. So here all this you are going to understood in detail. Okay. And yesterday, so I think so after completion of 1.5 hours, so power gone. Okay. So again I rejoined only some few members so watched the video. So intimate to your friends also to go through these videos. So these videos helps you so to understood the dynamic programming approach. Okay, so when should prefer, so how we should apply DP, how we can convert a recursive solution into DP, all this. Okay, and so ask them to subscribe. Okay, you also are watching, so subscribe and ask your friends also to subscribe. Okay, to get the notifications and to watch the videos. Okay, from the iCare Academy. Okay, and if any problem occurs, okay. So again, rejoin. So I'll also rejoin from my side. Okay, already I said this information. So in the beginning, first session also. Okay, uh, fine. So the program. So the next program is edit distance. Okay, so this is present in all platforms. So let me check from this one. Coding Ninjas. So here you can check. So this one, Austin, nearly some 22 companies. So interviews. Okay, it is from moderate level. Okay, and so the same program is present in lead code platform also. Okay, so relevant to this, so I'll give you task as one program. So you can easily finish that program. So although it's new for you, okay, although you feel DP as difficult, easily you can complete. So based on this knowledge, okay, you can check yourself. So first of all, understood. So this problem statement, so that clearly, okay, you know the path. So we are going to start with the recursive solution, and so finally we'll convert into the dynamic programming tabulation method. Okay, without memorization. So directly, so I'll finish the tabulation method because yesterday you already observed how much time it takes. Okay, for explaining one single program. First of all, we should think how to first we should understood the problem statement. Next of all, uh, we should think how to design the recursive solution. Afterwards, we should check how it's working in the backend with the help of recursion tree. Next of all, so for moving to the memorization, afterwards ending with the tabulation method, and so how values are getting filled in the backend. So for checking all this, it takes a lot of time. Okay, that's why directly with of recursive solution directly I'll end up with the tabulation method of dynamic programming. Okay, so I won't take a recursion tree next of all, uh, so fire table, whatever you observed in the previous session, all this. Okay, just so I'll explain the problem statement, recursive solution, and I'll show you how to convert to the tabulation method. Okay, already so far so 2 to 3 programs you observed, right? Okay, recursion tree, and next of all, so the table filling values, all this. Okay, that's why for reducing time, so I planned like this. Okay, so cooperate it, and so if you feel difficult, okay, at any point of your time, so yesterday I shown you how to draw the recursion tree, and so how values are getting filled in the table. So you gone through. Okay, so fine. And I forgot to tell you one more thing. So exams are conducting. So from iCare Academy, right? Okay. So don't fail to attempt so the exam. So check how the questions are asking. So whether you are capable of applying so the knowledge whatever receiving so from these sessions or not. So check yourself. Okay. So based on that, you came to know that so you need to practice so the more number of programs. Okay. So fine. So now I'll explain. So the problem statement here, so observe everyone. Given two strings, word 1 and word 2, return the minimum number of operations required to convert word 1 to word 2. Okay. So what operations are allowed here is given in the so next so sentence. You have the following three operations permitted on a word. Insert a character, delete a character, replace a character. Okay. So by just doing these operations, okay, uh, so we need to check, okay, how many minimum number of operations are required for making conversion of word one to word two. Okay, 1 minute. Next. So here, example one. So you can check now. So the word one is horse, okay, and so the word two is rose is given. With the help of same example, so I'm going to explain now. Okay. So for this, we need to print so the three here. Okay. So here, different possibilities were there, guys. Okay. So from those possibilities, we may get so the result from the any path. Okay. Yesterday, so you observed longest common subsequence also. Okay. So we may get results from the any path. Okay. So that result we need to print. So here explanation is given. Okay. Uh, so here I'm going to explain at any particular index what operations are required. Okay, what operations you need to perform. And so the second example, word one intention and word two execution is given. Okay, totally some minimum five operations are required. Okay, for making conversion of word one to word. It's given here in detail. You can study later. Okay, so directly I'll explain. So with the help of this example. Next. And they can check so the topics here it's from dynamic programming, so strings. Okay, and remember one thing, after completion of this, check so whether easily you can convert, whether easily you can design this program or not. Okay, so that is delete operations for two strings. Okay, so now I'm going to explain insertion, deletion, and updation operations, right? Okay. So among those operations, only you need to prefer one operation. So that's it, delete operation. In this program, I'm going to explain all three. So in those three, only you need to pick one operation. Okay. One operation, you need to complete this program. So remember this and so complete it later after completion of so explanation of this. Okay. So fine. Now I already told you, so what steps we need to follow for so writing the recurrence, okay? So once again, I'll type here steps to follow to write recurrence, okay? That is recursive solution. So have a look, everyone. So the very first step is what we discussed yesterday. So what we observed, I'll type here, okay? So observe. What is the first step I said? Express problem in terms of in terms of indexes, because so here so whether arrays or strings, okay, So we need to work with the index position values, right? Okay, index values. So first of all, we need to focus on taking calling function and next of all, so the called function, okay? So that one you can observe in the first step here, okay? So fine. Next. So what is the second step? So I said, guys, explore uh, all possibilities at some particular index, okay? At any particular index, okay? What are so possibilities were there, okay? So we need to gone through this. So dynamic programming, I said we prefer for optimization problems, that is for maximization or minimization. Okay. So but here, so we are going to get some different paths like in Fibonacci series and longest common subsequence you observe, right? Okay. I told you to complete the longest common substring also. Only need to make one small change. Okay. So I told you to gone through that program. Okay. Don't forget. So here, from among those paths, okay, we are going to get so the maximize and minimize result, but not, but the same thing. So we do not observe in greedy. So if you take knapsack, okay, so at each and every point of time, so we try to minimize the result, okay, minimize or maximize the result so that the overall problem result maximize. So we didn't, so we don't have so these men number of possibilities, and we didn't try to find the max or min of that, okay. So that is the difference between so both these two approaches, greedy and dynamic. Both are used for optimization problems only, okay. So but the way of applying so process is different here, okay. Next. So what I said, so based on some the problem requirement, so we change this third point, right? Okay. So here, what we need to do in all those possibilities, we want so minimum number of operations, right, required to convert string one to the string two. Okay. So observe here, find so minimum of so possibilities. Okay, and so the last one so is we need to stop so the recursion, right? Okay, so we are going to generate so the recursive function calls with this, okay, by exploring the possibilities, and so among those recursive function calls we may get so the minimum result from any one of the path, okay. So we are going to apply min, and finally we need to stop the recursion, right? Okay, so that one we observed as a base condition, guys. Okay, so remember these two four steps. Okay, let us see. So one by one. Okay, so first of all, I'll complete this one, and next remaining these three steps I'll explain with the sample example. Okay, so this one directly I'll type now. Okay, in the lead code platform. So observe everyone. Hmm. So what is given here? Check everyone. So within solution class, min distance method is given. So word one and word two passer here to this method, and we need to return integer value from this, okay, method. So the minimum number of operations required. Count we need to return here, okay. So this is from the count model, guys. Once again. Yesterday's session, longest common subsequence or substring is also from count model. Again, this is also from count model. Okay. So count model, sum model, I said max and min model programs are very important for both coding section and interviews. Okay. So remember this. Next. Now, first of all, what I said here, it's not possible to directly generate recursive function calls within this method because so this method contains only so string one and string two only we can pass. So that's it, right? Okay, it's not possible to pass so the updated indexes. So that's why what I did in the previous session, I taken so one extra so function call that is called f. Same function name I'm taking here. Okay. So I'm passing so the word one and next of all so the word two. We need to work with these two strings, right? Okay. I'm passing both word one and next of all, so the word to here. And apart from this, what I said in the recursion, so we are going to start working from the last index to the beginning index, right? So it's opposite to the iterative approach. In iterative approach, so we start working from the zeroth index to the so size minus one index, okay? But in recursion, we work from so the size one minus index to the zero index, right? So that's why initially, so I'm passing the length of word one, so the minus one. Next of all, so length of word 2 minus 1. With the help of this, we are going to get the last indexes, okay? So these index values I am collecting here. So within the called method, so observe everyone. Self address I am copying in the self. This self is I am getting once again copying into the self. Next word 1 I am copying in S1, word 2 I am copying in S2, okay? I'm reducing length, that's it, okay? Now next. So first word last index I am copying in I, second word last index I am copying in J. Okay, this is the very first step. Okay, express the problem in terms of so indexes. So got it? I hope you understood. First step is completed. Explore problem in terms of indexes. So now let us focus on this one. Explore all possibilities at some particular index. Okay. So let us take this example to understood. So this one, that is horse and so or voice. Now, so I is pointing at this index, guys. Okay, remember next or voice. Okay, so J is pointing at this index. Remember next. So at any particular index, so what are the possibilities? So we have. So now I'll explain. So in detail. So listen now. Okay. So the very first thing, so you need to focus here is okay. Let us do one thing. Let us consider so this character. Let us remove this character. Let us consider that. So we have so these four characters in the string one. Okay, in string one, so we have these characters. Okay, in string two, so we have ROS. So for suppose if both I position character and the next of all, so the J position character of string two are matching. Okay. Uh, so is there any is required to perform any operations, so insertion, deletion, or else updation? Okay. So no, right? So already both those two characters are same. Okay. Nothing is required. No operation is required. Right. Okay. No operation is required. So to perform at these indexes, okay. So this is one possibility. Remember everyone, okay. The first thing is if for suppose so I position character of string one and J position character of string two so are matching. So no operation so is required, okay. Um, simply we can generate recursive function calls to the so previous indexes like this I to the previous index and next of all so j to the previous index. So this first step I'll complete. So observe everyone, afterwards I'll explain so the remaining possibilities. Okay, first observe this everyone, let me complete this. So have a look, everyone. So here I divided the entire program into multiple partitions. Okay. So each and every partition I am explaining separately so that you can understood in detail. So what I am saying here, if for suppose S1 string of I position character, S2 string of J position character matching. What we observed in the previous program, that is longest common subsequence, we added plus one to the result. Okay, we incremented so the count by one. So because there it's required to find the matching characters in both the string. Okay, so but here Matching characters, it's not required. If not matches, what operations we need to perform so in that particular index, okay, it's required. Okay. So in that scenario, we should go for adding one. If not matches, we should go for adding one. And so next of all, so what are the next other possibilities we need to perform? So in that index, we need to work there. Okay. So first, let us complete this one. For suppose S1 of I position character, so if matches with S2 string to of J position. Okay. So what I am saying here is, okay, simply generate recursive function call. So by updating, so I and j, so indexes to the previous positions. Okay, I and j variables to the previous indexes. So observe this, everyone. Return. So self dot f of s1 and s2. I am updating to the previous index, and j also I am updating to the previous index. Okay. I hope so. This point is clear for everyone. Okay, now nothing is required. Okay, so to add to the result, just we are adding, so the zero to the result. Okay, we are generating, so the recursive function call. Zero is not required, just for understanding, so I taken here. But suppose if not matches, okay, so then in that scenario we need to add plus one. Okay, and so what are, so the other possibilities we need to think? Okay, if we are adding, so the plus one means, so any one of the operations, so we can perform insertion, deletion, updation. Okay, so either by insertion at particular character, and so by moving to the previous positions, and deletion or else updation, we may get the minimum result. Or else by deleting some particular character, and so by moving insertion and updation, we may get the minimum result. We cannot say. So that's why simply we are going to generate a recursive function call. So from that, so wherever, so we'll get the minimum result, we'll collect it and return to the, so main. In this way only you should think. Okay, so that you can easily design, so the recursive solution. And so in top level only you should think. If you think in detail, in depth, okay, you feel difficult. So you need to find the patterns here. Okay, for those patterns you need to design with the recursive solution. Okay, so fine. Now let me finish this. Okay. Hmm. Okay, fine. Now let us take two strings as it is now. So S1 string as horse and S2 string as ROS. Okay. Now listen. So it's clear now. I and J position characters are not matching, right? Okay. So if not matches, so what I said, we have so three operations you can perform at that index. So first, let us take so insertion operation. Okay. Insertion means, so in any one of the string, you need to insert the character, so which is matching at, so which is matching on the another string, and so that you need to update the index accordingly. Okay, so I'll do one thing. So I'll go for inserting some character in the string one. So to match, so string one and string two characters. So what is the character? So present in the string to here, it's S, right? Okay. So on inserting some yes, on inserting some so S character in string one, okay. So chances were there to match, right? Okay. So now it matches. See, listen, remember one thing. So here insertion means it's not possible to insert so the character, okay, in some string. So just we need to imagine here, so that on inserting some particular so character into the string one or else onto the string two. So if matches, what we need to do? Okay, here. So here S1, S and S are matching here, right? Okay. Now, so I is still pointing to the E character only. Okay. So just what I said, we should imagine that some character is inserting. So next to the I position here. So that's it. Okay. We are not so really inserting so that particular character over there. Okay. So we are inserting some character and we are making some particular character in the string to matching, okay? And after that, it's not required to update so the I because so I we didn't take into that character. So just so we taken so that it's matching and only we need to update so J to the so previous index here, okay? So this is the point you need to remember. Only we need to update so the J position to the previous index if you are performing the insertion operation. Okay. So for insertion operation, guys, we need to keep I fixed and we should update J to the previous index. Okay. Remember this. Next, I'll type it. So once again, okay, at the ending. Now let us think about so the next operation here. Okay. Next operation is so let us take so the deletion. Okay. So that is on deleting some particular character in string one and so updating so to the previous position. So chances were there to match, right? Okay. Observe this. This is the best example. Okay. Easily you can understood, right? So by what I said previously, are inserting some character into the string one, so chances were there to match with the J position character. In that scenario, only we need to update so the J to the previous index. So now, on just deleting some character, I mean, on just by updating so the I index to the previous position, so some chances were there to match, right? Okay. So this is the next thing. So what I am saying here for deletion, we need to take I to the previous index and we should keep J fixed here. Okay. So because by moving I to the previous and J is fixed, then only it's matching, right? Okay. So I hope you understood. And so what I said for insertion, so it is I fixed J we should update to the previous index. It's opposite, okay? Easily you can understood now. Next, let us take so the another thing. Let us take so again the original string here, okay? Now observe everyone. First, suppose what is the operation? So the remaining now, okay? At at particular index we need to gone through, okay? What operations so we can perform here and performing some operations so the how we need to so generate so the recursive function calls we need to think here same thing we are performing. So now observe and just so updating I position character with the yes, okay, so chances were there to match, right? Observe here, initially I inserted some character next to the I position. Afterwards, I updated I to the previous index. So it's matched. Now I'm performing so the replace operation on the so ith position here. Okay. So now on performing replace definitely matches, right? Now both I and next of all, so J we need to update to the so previous indexes here. Okay. So that is required. So this is nothing but a replace operation, guys. Okay. Both I next of all, so J indexes we need to update to the previous positions. So three function calls we need to generate. So I, j minus 1, I minus 1 and j, I minus 1 and j minus 1. So after performing some insertion and on moving to the deletion and next of all so to the updation, so afterwards on moving to the replace, so chances were there to get the minimum result. Okay. So or else after performing so the deletion operations and on moving to the replace and so performing insertion operations, so chance were there to get the minimum result. Okay. Likewise, some different so paths were there. Among those paths, we may get a minimum result from any path. Okay. So these are the possibilities. Among these possibilities, we need to find so the min here. Okay. Among all these possibilities, we need to find the min. So but min and max function, so we can use for two arguments, right? Okay. So I'm going to apply so min function like this. First of all, first function that is for insertion function. So I'll take within inside min, and next to that, so in place of second argument, I am going to take so min like this. Okay, min of function 2 and so function 3. See, what is going to be happened is first of all, so from these two functions, we are going to get the so minimum result. With that result, so f1 function result is going to be compared, and finally we are going to get so the min. Okay, and so while performing so any one of these operations, what we need to do, we should add plus one to the result. By adding plus one to the result, we should generate so these recursive function calls here. Okay. So I hope you understood. So the second step and third step. What I said, at some particular index, we should think about so the possibilities here, okay? And among those possibilities, we need to find so the min here, okay? So same thing. So we are performing now. So have a look. So fine. Let us finish now. So what I said, return 1 plus min of. So first function is self dot f of S1, S2, and I'm updating to the previous index. Okay. Sorry. So let us take insertion operation. So the recursive function call here. Okay. What I said, we should keep it in the same position. We should take so j to the previous index. Okay. And inserting so I and j position characters. So the matches, right? Okay. Sorry, and inserting some hypothetically inserted character in J position characters or matches, right? Okay. So in that scenario, only we should update J to the previous index. Okay. I we should not update. Next, what I said, in place of second argument, we are going to take min of function 2 and function 3, right? So the function 2 is for deletion. S1, S2, at the time of performing, so the deletion, so we need to update to the previous index. By deleting some particular character, so in string 1, so chance were there to match with the string 2 J position character. So there is a second function, third function call, the second one, and so last one for replace. If replacing some particular character in any one of the string means, so now definitely matches, right? Both the I and j positions we need to update to the previous indexes. Okay. So observe here self dot f of s1, s2, I minus 1, and next of also the j minus 1. It's a lengthiest one, but so easily you can think. Imagine if you directly want to think with tabulation method of dynamic programming, so it feel very difficult. Okay. So, but with recurrence, easily we can do it. Next, finally, so what I said, we should think about so the base condition here. Okay, we explored all possibilities at particular index, and after that, so we find out minimum of so the all possibilities. Those possibilities here, and finally we should end the so recursion here. Okay, base condition is very important. So yesterday you observed the base condition, so the similar to this program, but one small change you can observe now. Okay, so have a look, observe carefully now, everyone. For suppose, let us consider that. So this is string one. I is pointing to so this position. Okay, and so second string. So it's so let us take so the B. Okay, and so this is string 2 means we compared so all the strings. Okay, so now what is happening here, I and j position characters are matching, right? Okay, if matches, what I said, simply we should generate recursive function calls to the previous positions, right? So here I moves to the 0th position. Okay, so but j moves to the so -1 position. This is B character is present at 0th position, right? 0 and 1. So our matching, if matches, simply we are generating recursive function calls to the for previous positions. Okay, J moves to the -1 and I moves to the 0th position. Is there any possibility to so make comparisons here? Okay, is it matches? So no. And next of all, if not matches, is it required to perform so the any operations here, insertion, deletions, updations? Nothing is required, right? Okay, so whatever, so listen, simply if j moves to the -1 position means, okay, whatever the I is pointing to some particular index, right? Okay, so those index values simply we need to remove. Okay, and making deletion only, so I also moves to the so -1 position, right? I also finally reaches to the -1 simply so by deleting so the whatever the characters pointing here. Okay, so tell me one thing, to which position so I is pointing here. Okay, so by the time of pointing j to the -1 position here, so it's 0, right? So 0 means, so what we need to do, how many characters we need to delete? One, right? Okay, so means the thing is we need to return, so simply I plus 1. So whenever j becomes so the negative. In previous session, what I said, whenever so j becomes negative or else I becomes negative, there are no characters are going to match, right? Okay. Simply we returned so the 0. So but here, so we need to do this. So or else I'll take one more thing. I'll take one more example. Clearly, you can understood this. Observe at once. Hmm. Let us take so next this one. So easily you can understood. I is pointing to here, and so J is pointing to here. So characters are matching. So what happens? J moves to the so -1 index, okay, and I updates to the so index 1, okay. So now whenever J becomes so the negative, so simply what we need to do? We need to delete all the characters, right? Simply on deleting only, so it's not required to perform insertion operations. It's not possible to insert so any characters in the negative indexes. Okay, it's not possible to replace operations on. Only one thing is remaining. So deletion operations. That deletion operation count. So we need to directly return. That is what I am saying here. Okay. So simply, if I is pointing to the 1, so how many characters we need to delete now? So 2. Earlier, what I explained. If I is pointing to 0, we need to return 1. If I is pointing to 1, we need to return 2 characters. Actually, index starts from 0, right? Okay. So, but we need to return how many characters we need to be deleted here. So that's why remember, so we need to take I plus 1 here. Finally, we need to return I plus 1. Same thing applies for so this one also. Okay. Whenever I becomes so the negative, so we need to return so the j plus 1 characters. Okay. Or else I'll explain. So observe everyone. ABC let us take as a string 2. Okay. Next, same thing, vice versa. I is pointing to here. Okay. So matches what we do. Simply I points to the negative index. Okay. So this is 2, 1, and 0. So j points to the index number 1. Okay. Whenever I becomes so the negative. Okay. So whatever the characters present from j to the 0th position, so all these has to be deleted. Means totally how many we have to delete it? 2. Okay. So if j is pointing to the 1 on returning, so the j plus 1, so we are going to get 2 result. Okay. Just like so previous we got result 2, right? Okay. So I hope you understood the base condition here. Okay. So let me complete this base condition part and I'll execute. Check whether so it's executing or else we are getting TL error and observe carefully how we can directly convert into the tabulation method here. Okay. Yesterday I explained clearly so how to take a 2D array with the row size plus 1 and column size plus 1, how to take so the loops and how to take so the entire program inside the loops, all this. Okay. Now listen carefully once again. Okay. That's why so I'm explaining so the more than one program here. At least so if one from number of programs, okay. So listening, so chance were there to understood, right? Next. So let us see now. Okay. Observe everyone. If so I becomes less than of 0. Okay. So then we need to return 1 minute. Sorry. We need to return j plus 1, right? Okay. L if j is if you take so elif statements like this, you feel very easy. Okay. So while converting into the tabulation method, because for recursive function calls, we are going to take return. Okay. You can use outside if or else whatever it may be, it's fine. But we are not going to take return statements, right? So that's why we need to use elif. Okay. This one also we need to change it as elif. So here for suppose if j is less than of 0, we need to return so the I plus 1. Okay. So this is the recurrence. So what recursive solution for this program? Okay. First, we expressed a problem in terms of indexes. Next of all, so we think of possibilities here, and among those possibilities, we taken min here, okay. And next of all, find with the help of base conditions, okay. We stop and recursion. Same thing you can observe in all programs, okay. So observe. Let us run and submit, okay. As base case executed, let us submit now. Yes, we got a TL error here, okay. You can check now. So what is how many test cases passed here? So check. Only 27 test cases passed out of 1149. So this is the last executed input. So check. So these are very big strings, okay? So not small ones. Imagine how many recursive function calls are generating. So here, so that's why for all those test cases, so it's failed here, okay? So that's why we need to move on to the so tabulation method now, okay? So I hope so you remembered the steps to convert into the tabulation. So again, I'll explain in this program. Listen carefully now. So the very first step is we need to pass. So length of string one and next of all length of string two. So from the calling method here, because we need to pass the string one and string two length. With the help of those sizes, we need to create some extra 2D array here. Okay, indexes we are going to generate. So the loops, okay, it's not required from the function. And so second change is in place of I and j variables, we need to take so row and column variables, okay, row and column size variables, because so in loops we are going to use I and j variables, right? Okay, so you'll get problem with the variables. That's why so we need to change into the row and column variable. But initially, if we take in so in and m means you feel difficult to convert into tabulation. In loops, we are going to use I and j variables only now. That's why you are going to feel very easy to understood the program. That's why while writing so the recursive solution, we need to take I and j variables only in the call method. But so while taking so the tabulation method, you should change it. Okay. So now the next step is we need to create some 2D array here. Okay. So let us take so the DP array. So initially what I said, we need to fill all memory locations with zeros, right? List comprehension with the help of list comprehension. So I'm filling all 2D array values with zeros. Okay, and we need to create some extra 2D array with size plus 1. Okay, Fibonacci series we created like this, right? N plus 1. Likewise, we are doing. So with the n plus 1 and m plus 1 size, we are going to create so the 2D array here. Okay, so listen now. For j in range of m plus 1, next for I in range of so the n plus 1. Okay, so for each and every I value, what I said, so here this is going to be executed. Okay, one list is going to be placed in each and every row. Okay, so this is going to be happened in the backend. Next, after this, what is the next change? We need to take so the loops, right? Row loop and next of also the column loop. Okay, so we are going to start filling from the so bottom. So that's why it's this method is called bottom up approach. Okay, so for I in range of n plus 1, and next for j in range of m plus 1. We should take so the two loops here, row loop and next of all column loop. Okay, so next thing is we need to take so the entire program within so the for loop of G. Okay, I'm taking entire so program inside for loop of G. Fine. After this, we should start so the making conversion here. Okay, this part is important. So listen carefully now. What I said in the previous session, it's the longest common subsequence. Okay, so we don't have negative indexes, okay, in the loops, right? We should focus on base condition for so the 0th row and next of also the 0th column, okay? So observe here if I is pointing to the 0 or else if j is pointing to the 0, what you need to do, okay? And one more thing I said, in place of return keyword we need to take so the dp array here, okay? So I'm doing the same. In place of return keyword I'm taking so the dp of iz here, okay? And here we need to make one small change. Okay, so in this program, what is that change? I'll explain now. Here also in place of return, I'm taking so the dp of iz. Okay, observe carefully how I'm making so the conversion here. Okay, so here if I value is 0, okay, so we need to fill so that particular, so the row with the, so j value, so that is with the column values. I said 0 row and 0 column, so we are going to use as dummy. So in the previous session, that is with longest common subsequence. Okay. So here I and j means, so we are going to fill with those values. With those values help, we are going to fill so the next upcoming values, right? So this is the change you need to do here. So dp of ij is equals to j here. So dp of ij is equals to I. Okay. 0 row, and next of all, so the 0th column we are going to use as so the dummy. So entire first column, 0th column, we are going to fill with the row values entire. So the first row is going to be filled with those column values. Okay. But so we are going to make so comparison. So from actually when the control comes to this else if block here, so whenever I and j values are not becomes zero only, right? But from where we need to start making so the comparisons from zero and zero to positions only, right? Okay, that's why. So what change? So we did in the previous session. So we taken like this I minus one and next of also the j minus. Simply it's opposite, ma. So wherever you taken, so the plus one means we need to take. So here I am talking about in the base conditions. Okay, we removed that place of I and j. We are taking so next I minus one and j minus one. So now what happens? It starts making comparisons from the zero and zero positions only, right? Okay. And what is the next change in place of return keyword? So we need to take dp of ij. Okay, and this one zero, it's not required. Okay, and what I said, in place of function we need to take so the dp array, and we need to remove the strings. We should take so I minus one and j minus one within subscripts. Okay, I minus one and next of all, so the j minus one we need to take it so in the subscript. I hope you understood. Likewise, observe how I am making so conversion of the lost else statement here. Okay, again, so in place of return, so I am removing return, and I'm including so the dp of ij here. Okay, and I'm removing so the function call. In place of that I am taking dp, and I'm removing strings. In place of so for I and j minus one we need to take subscript. Okay, I hope you understood this. So how I'm making so the changes. dp of I minus 1 and next of all so the j, and so here it's dp of I minus 1 and next of all so the j minus 1. Okay, fine. Finally, so after completion of so the both the loops, okay, and so ending of both the loops, what I said, the result is going to be stored in the so last positions, right? Okay, last row and last column. So we are going to get result in the row and column position. That's why we created so the 2D array with row size plus one and next of all so the column size plus one. Yesterday's session also I informed this. Okay, so I'm returning so the same here. Okay, that is return dp of sorry, dp of n m we need to return. Okay, so this is the way of converting into the so dynamic programming, so the tabulation method. Okay, I hope you understood. So if you found any problems, so ask with me, so I'll explain, no problem. So let us check. Let us run and submit now whether it works or not is completed. Let us submit now. So check whether it's executing or not, and it's taking very low time here. Okay, 59 milliseconds. So that's it. So there is no problem in it. Earlier we got time limit exceeded error. Okay, now it's resolved here. So I hope so you understood this one. I'll give you some 2 minutes time. So check this, everyone. Okay. So if you have any doubts, you can ask. So, okay, fine. Let us move on to the next important program, that is a 01 knapsack. Okay, so that is from uh, some model. Next two programs you are going to observe from some model. These two programs are from count model. Okay, longest common subsequence and next of all substring. So edit distance. I given one more task. Okay, so delete operations required for making string one and string two. All this comes under so count model. Now I'll explain some programs on some model. You just gone through some other programs so based on so the some model. Okay, so fine. So 01 knapsack. So I'll check here. This one nearly asked in some 40 plus companies. Okay, then revert. So it is from the moderate level. Okay. So first observe the problem statement, everyone. Okay. A thief is robbing a store and can carry a maximum weight of W. Into his knapsack. W represents so the weight here. Okay. So in kgs, whatever it may be, units. So next, there are n items available in the store, and the weight and value of each type item is known to the thief. Thief is very intelligent here. Okay. So he know the weight and value, but so how we should pick the items yesterday we discussed in detail in greedy approach. Okay, so if we directly go for picking the maximum value items, okay, he is not going to get the maximum profit. Okay, so based on if we go for picking the per kg cost, if you go for picking items based on per kg cost, his profit is going to be maximized. Yesterday you observed that. Okay, so but now observe what is the thing here? 1 minute. Uh, Fine. Considering the constraints of the maximum weight that a knapsack can carry, you have to find the maximum profit that a thief can generate by stealing items. Yesterday, you observed fractional knapsack, right? Okay, so easily you can understood this one. You won't feel any difficult. Okay, fine. So that's why from my side also I'll complete quickly. So observe note information here. Okay, yesterday what you observed in the note? Okay, allowed to break the items, right? But here the thief is not allowed to break the items. Okay, I told you so the different types of items you should consider for these programs here. Yesterday I told you that breaking is allowed means some fruits, vegetables, so you can consider like this. Okay, you can take it in partition, but for this program you should consider items like fridge, so washing machine like that. So it's not possible to break it, right? So now, either we need to pick some particular item or else not pick. That's it. These two are the possibilities. You are going to observe at some particular index. Easily you can understood now. Either we need to pick some item or else we should not pick some item. But we didn't done like that in the previous yesterday greedy approach program. Okay, so we performed sort based on per kg cost. Each and every product we go on for collecting based on decreasing order. If not possible, we collected some partition at the ending. So, but here you are not going to observe like that. So by picking some particular item and moving in some path like not pick and pick, we are going to get the maximized result. Or else after not picking and on moving, so the pick and next of all, so the not pick, we may get so the maximized result. We cannot say. So from any path, we are going to get so the maximum result. Okay. So on drawing, so the recursion tree, all this you can understood in detail. I told you already. So you do that work after completion of explanations of program from my end. Okay. Fine. So here some example is given, number of items and a knapsack capacity 10, items 4 is given, okay. So with this weights and values, okay, so he is going to get the best. So the result as 13, okay. So I'll explain with one of the example, so don't worry. And next, here some other examples are given, okay. So after completion of my explanation, so try to go through this, okay, and understood. So again, so observe how we should consider these steps, okay, for this program. So again, it's the same express problem in terms of indexes here, okay. So two arrays are given here, okay, right? One is this one, weights array is given, another one is values array is given. So both these two arrays of same size, okay. So that's why it's required to pass size minus one, okay, index, okay. And next of all, after collecting some item, okay, so what we are going to do, we are going to get some profit, that one we are going to add, okay. After adding, so we need to reduce the particular, after collecting some product, okay, item, we need to reduce that weight from the knapsack capacity, right? So that's why we need to pass knapsack, okay. Knapsack capacity to the function. With the different knapsack capacities, we are going to generate recursive function calls. And next in the tabulation also, you are going to observe the same, okay. So with the different knapsack capacities, so what type of items we can fill, so that we are going to get the ending result, okay. On taking so the table, you can understand in detail, okay. But I'll table I'll display at the ending, so just gone through at some at glance. Next, so we need to explore so all possibilities at particular index. So here you are going to observe so just two things. So that's it. So that is pick and next of all, so the not pick here. Okay. So here it's not 1 minute. Here it's pick or else or not pick. If we are not picking, so the particular product, what you need to do. If we are picking, so I told you this is from the sum and max model in combination. Okay. So here, if we are picking, so we go for, so we are going to get some profit, right? So that partition you are going to observe here. I'll explain later. Next, after this, so either after picking and next of all on moving, so in different path we may get so the maximized result, or else after not picking and next of all on moving in the different path like pick and not pick, so we are going to get so the maximum result. So here once again, we need to make change here, find maximum so of these possibilities. Okay. In among these possibilities, we need to find so the max, and finally we should end up with the base condition here. Okay. So first, what I said. First, let us complete this part. Okay. Taking so the calling function and call function. Afterwards, with some sample example, I'll explain these three steps. Okay. Same format I'll continue for all the programs here. So fine, let me complete. So this one. Let us reset the code. So observe. Here you feel better in the Coding Ninja's platform because here function is given. Okay. So it's not a method. That's why you cannot observe self keyword also here. Okay. It's not required to generate so method calls with self keyword. Okay. So fine. What I said, we need to generate recursive function calls with the different indexes of two arrays. Okay, indexes, and we need to generate after collecting some item, we need to reduce knapsack capacity and we should generate the function call, right? So that's why I'm taking one recursive function call here, so called f. Okay, I'm passing values and next of all so the weights, and apart from this I'm passing so the last index of both these two arrays, that is n minus 1, and the knapsack capacity I'm passing, guys. Okay, so fine. Let us go for defining so the called function now. Okay, define f of so values. Next of all, so the weights. Okay, and let us take n minus 1, let us collect into the I variable, okay, and knapsack capacity, let us collect in the lowercase w only, okay. Now let us start so understanding so this one, how to design so the program for this, okay. I'll explain so the first two possibilities and I'll type so the program here now, okay. Observe everyone. I think so. In greedy approach we taken so this example 10, 20, 30. Weights list we taken, and next of all this one 60, next 100 and 120, I think so this values list we taken, and so knapsack capacity we taken some 50 kgs, okay. So right, fine. So listen, let us take so this value. We are starting working from so the last index, right? Okay, let us consider so the weight of so this item is some 60 kgs. Okay, is it possible to pick this item here? Okay, no, right? Because the knapsack capacity is 50 here. So what is the condition? So we used in the greedy approach program. So once again, I am memorizing. Okay, so observe everyone. Weights list weights list of some particular I position. This is I position, guys. Okay, I position if it is less than or else equivalent of knapsack capacity. So then only it's possible to collect so that particular item, right? Okay. So otherwise it's not possible, right? So same thing you are going to observe now. Okay. So let us check this one now. 1 minute. I'll erase this. Okay, and I'll write once. I'll type once again. If I suppose 60 is present in that, okay. So in this, I if is pointing to this one, right? Okay. So this positions here. Now 30, it's clearly less than or equivalent of 30 is less than or equivalent of so 50, right? Okay. Uh, so initially we take so pick as 0 because if for suppose this condition fails, okay. Uh, so we need to check maximum from pick or else so the not pick, right? Okay. So otherwise we are not going to have so the pick variable. That's why initially so pick variable we take it as 0 outside, and if for suppose this condition is true, next. So what we need to do? We should collect this value. Okay. Initially, so we'll take so by adding so values of I, that particular position value, so by adding we are going to generate so the recursive function call here, so the to the previous index, right? It's not required, so we are picking so particular item is we are collecting that value. Okay, earlier we taken +1 here. By taking +1 we generated recursive function call, but this is the sum model program. By collecting so that particular so value, we are generating recursive function call to the, we should generate recursive function call to the previous index. So fine. So how we should generate this recursive function call means, so there is no change in the weights list, values list. Okay, I index we should update to the previous position. So you observe this, and apart from this, knapsack capacity also we need to reduce, right? So how much item, what item we collected? 30 kgs item, right? So it should be reduced to 20. Okay, in the next recursive function call, it should generate so to 20. That's why we need to take this recursive function call. Observe here, everyone, carefully. So knapsack capacity we should so reduce with weight of Sorry, 1 minute. So I'll take here. Values of I on adding, and so we need to generate recursive function call. There is no change in the weights list. So value array weights list as is I'm passing. Index we should update to the previous position, and knapsack capacity we should reduce like this. From knapsack capacity we should reduce so weight of that particular position. Okay. So this is the recursive function call we should generate. So for the pick here. Okay. Uh, so to pick, we should assign this one. Initially, we take so 0. If for suppose this condition not executes, we won't get any value here like this, right? Initially, we are going to consider this one 0. If for suppose if we are picking, so we are going to get some value. Value gets updated in pick variable. That value we consider. Okay. Next. Now let us take so not pick here. So not pick means, so if we are not picking, we should not collect anything. For suppose let us take, so we can collect, so this one also here, okay? And after that again, knapsack capacity is going to be reduced to 0. Index is going to be updated to here, okay? Is it possible to collect, so this one? No, right, okay? So now in this not pick, what you need to do? Listen. Simply, it's not required to add anything to the result. So we should add 0 and we should generate the recursive function call here. Weights list, value list. So we need to pass it and just we need to update so the previous index. Okay. What I said initially, if we have so the 60 here, okay, it's not possible to pick this one. Might be by moving to this position, so we may get, so we may pick so this one. So because knapsack capacity is 50, in this position we have 20 gauges item. Simply we need to update index only. There is no change in the knapsack capacity if we are not picking. Okay. So these two things you need to remember here. So we are going to get so results not pick and next of all so the pick. Okay. Not pick and so pick we are going to get, so among these two we are going to get so the maximum result so from any path. Okay, and we need to collect it. So these two are, this is second and third point. Okay, so finding so the all possibilities are some particular index. Okay, pick and not pick, and so next one is maximizing of all possibilities here. Okay, and finally, I am going to explain so the base conditions so later. First, let me complete so program up to here. Okay, so observe everyone. So what I said, if for suppose if we are not picking, okay, what I said simply we should add result 0 and we should generate recursive function calls so like this values next of all so the weights. Simply we should update so index, okay, to the previous position. That's it. There is no change in the knapsack capacity. Okay, fine. For suppose pick, let us take so the pick at particular index. So we need to take so both here. Okay. Initially, if pick if condition not going to be executed, it is going to collect so 0. And for suppose if this condition is going to be become true, it is going to collect so the result. Okay. So listen, observe everyone. So that is if weights at some particular index, okay, if it is less than or equivalent of knapsack capacity, okay. So then what we can do is we can pick that item. If we are picking so that item is, we need to consider so that particular item value profit, okay, into the result. Values of I we are adding and so generating recursive function call here. So for values, next of all weights, again here also we need to update index to the previous position Knapsack capacity also we need to reduce now. That is with this one. Knapsack capacity we should reduce. With this program, clearly you are going to understand how difficult it is to directly design with DP tabulation method. Okay, so fine. And then what I said next of all this? Okay, we need to return so the max of these two, right? Return max of pick and so comma not pick. Pick and next of also the not pick. From any one of these two, so we are going to get so the result, maximize result, okay? Need to take it. Next, finally, we should think about so the base condition, okay? So now, so no thing we need to think about. So on moving to the negative indexes, okay? So here for these programs, we need to think about so when we reach to the zeroth positions, okay? There we compared with the two strings, okay? That's why if any one of the index moves to the so the zeroth position, we need to that. But here we are not making so comparison of two arrays here, okay? So that's why we should not think like that base condition. We should think about like this. That is when we are at so zeroth index. Okay, what we need to do? What type of possibilities we have? Okay, we need to think about it. So got it. So listen. Let us work on it. Okay, so observe carefully. Uh, this is weights list. Okay, and so 60 is values list and just I'm talking about zeroth index, guys. Okay, so this is zeroth index. Okay, if so, I is pointing at zeroth index. Okay, what do you need to do? For suppose so the knapsack capacity is so 20 kgs is remaining. Still, we can keep some 20 kgs product inside so the knapsack. Okay, so why can't we can take so we can collect so this item. We can keep so this item into the knapsack, okay, right? So fine, this is the thing you need to focus. Means once again we are going to use the same waste, same condition, whatever you observed for picking, okay? So that is if weights of, but here directly we are going to check with zero position. If weights of zeroth position, if it is less than or is equal to of knapsack capacity, yes. So directly we are going to collect so this value, right? We are going to return so that particular so values list of zeroth position value. Zeroth position value we are going to return to the pick or else so the max not pick to the previously generated recursive function call. Based upon that, it is going to take a max of pick or not pick. Okay, it is going to return results to the previously generated function calls. This is what is going to be happen. For suppose, if we take knapsack capacity as, sorry, if we take so weights list as zeroth position index, we have so the 30 and next of all so 60. Now I is pointing to this index, zeroth index, okay. So nav weights of zeroth position value is 30, okay, and so the knapsack capacity is 20 here. Is it possible to pick this? No, right? Okay. So in that scenario, what you need to do? If for suppose this condition becomes true, okay, we need to return so this. If not, so what you need to return? Zero. Some model programs how we start so I always told you one thing, so that is exactly opposite to the loops we design so the recursion program. Initially some model programs we start by storing result, storing variable to zero, right? Okay, so but here finally we end up so by returning so the zero. In count model programs also you observe the same, okay. So these steps you are going to observe whenever so we are at so zeroth position. Okay, if we are at zeroth position, so might be so it's possible to collect so zeroth position item. So if it is if weight is less than of knapsack capacity, or else if it is not less than, so we are going to return so the zero means value we are not taking, right? Okay, we are not taking item means we are returning so the zero. Okay, so this part let us complete and let us check whether it works or not, or else we are going to take a time limit exceeded error. And afterwards, I'll show you so how to convert into the tabulation method. Okay, all this observe carefully, guys. Okay, so actually now these two programs are different when compared to the previous ones. It's not same. Okay. You already observed. So the variables, all this. Okay. How I am going to make so creation of 2D array. Observe all this. Okay. Clearly. What I said. So if weights of 0th position, if it is less than or is equals to of knapsack. Okay. Pasty. So then you can collect so the values of zeroth position either so it may returns to here so or else to here. Okay, after returning so it is going to collect so the max, okay, of this. Finally it's going to be executed. For suppose if this condition so the fails, okay, so it is going to return so zero here. Okay, so this is a 01 knapsack program. So recursive solution, let us run and check. So base test cases are executing here. 1 minute. Yeah, base case is executed here. Let us submit now. Here itself you can understood that. So we are going to get a TL error now. Okay. Yeah, time limit exceeded out of 11 test cases, 6 test cases so passed. Okay. So the common causes of time limit exceeded errors, so here remember, okay, might be if you do not update so the variables properly. Okay, in that scenario also we are going to get time limit exceeded. So don't think that so always the cause is taking too much time. So you can observe the second point here. So the second point is takes too much time than allowed constraints. Okay, so for that particular constraints which you should think about it. That is different. And sometimes, if you do not update variables properly, also we are going to get so time limit exceeded errors. You should gone through this. But remember, although if you are using so the better optimized solution, so if you are getting time limit exceeded error means you didn't updated so the variables properly, and it may cause us infinite loop. Okay, infinite loop means it takes more time, right? It never ends. Okay, so definitely you are going to get time limit exceeded errors. Okay. I hope so you understood this. Now I'll explain so how we should make so the conversion of this. Okay. Observe everyone. So the very first step of what I said, so actually we need to make change in the calling so function, right? So earlier, so we passed last index. Now we need to, so based on that size, we need to create some 2D array here. So this n variable I'm taking so asterisk as n here. Okay. So fine. Next, first of all, the first step is okay. So creating some 2D array here. Okay. So but here remember one point. So you can create so 2D array with so n plus 1 and next of all so the knapsack capacity plus 1 because so we are going to check with the different knapsack capacities whether it's possible to keep that particular item or not. Okay. So first point, so observe everyone carefully now. But suppose let us take knapsack capacity 0, okay? So knapsack capacity as 8, okay? We are going to create so 2D arrays with different knapsack capacities like this 2, 3, 4, 5, 6, 7, so 8 and all this, okay? So observe here, how many heads are required? So 0 to, this is the dummy row, okay? Dummy column, okay? So these are the actual knapsack capacities. So let us take n value so as 4, okay, 4 items were there. So first item 0 1 2 3 here it's not required, okay. So this one we taken for the array size, right? Values list I'm typing here, so observe everyone. For suppose let us take weights list 0 position value is so 4, and so on collecting this one we are going to get profit 10, okay. So is it possible to keep this item within so the zero knapsack capacity? No, right? Okay. So we are going to get zero here, zero here. Within 1 kg knapsack, is it possible to keep this item having weight for? No. Okay. So 2 kgs knapsack, not possible to keep weight for item. Zero in 3 kgs knapsack. So it's not possible to keep 4 kgs item. Here also zero. But from here it's possible, right? Okay. We can keep 4 kgs weight item within the 4 kgs knapsack. Okay. So from here onwards, okay, we need to fill the values. With what values we need to fill here, it's important. Okay. So what we need to do if it is possible if we are taking collecting this item means we need to collect this profit, right? So that profit we should keep here. So I hope you understood. This is the first thing, base condition itself I am explaining now. If we are at so 0th index, how we need to fill the 0th row I am explaining here, okay. And now within 5 kgs knapsack, 6 kgs, 7 kgs, 8 kgs, why can't we keep it? Because all these are, observe here, weight of I if it is less than or is equals to of knapsack, okay. So here in place of this we are going to take j variable because within j variable we are going to collect all these column indexes, okay, column positions we can keep all these, right? Particular 0 position character 4 we can keep, so inside all this 10 10 and all this we can do it, fine. So 1 minute. I hope so. Audible. It's not audible. So wait for 1 minute. I hope so. Audible. Not audible. So wait for 1 minute. Fine. No problem. So let us complete so this process now. First of all, I hope you understood. We should create So a 2D array now, okay. So size is like this with the knapsack capacity plus one, okay, because we need to get some nine values and there is no change in the so size here. N value with same n size we need to create it, okay. So that is the change you are going to observe from program to program here. So observe zero for 1 minute. Yeah, fine. Naps first of all, so columns we should take for uh, knapsack capacity size, right? Okay. And so why I'm including plus one, I hope you understood clearly now. Okay. And there is no change in the rows loop here. You can create so row loop for so the n here. Okay. And now what is the next step we need to focus? We should check whether if we are at 0th position, 0th row, how we should fill the values. Okay. First, let me complete so this one. So listen now. How we are going to fill values in the table also just now you observed, okay? So likewise, so think about how we are going to fill for remaining, so the cells also. First, let us take, so the 0th row, okay? For here, I'm taking, so the loop for columns, guys, okay? So here, I'm taking loop for column here, okay? So from when onwards, we can start, sorry, wait. From when onwards, we can start, so filling values here, right? That is from weights of zeroth position value, right? From from this column onwards, okay, from this column onwards up to the so knapsack capacity, we can fill the values. So same thing you can observe from 4 onwards, okay. So we can fill up to the knapsack capacity values we can fill. So values of zeroth position value we can fill. So from so the weights of zero position value wherever it's matching with the knapsack capacity up to the until to the ending, right? So that's why I observe weights of zero. I'm taking in the so starts position and next of all knapsack capacity. So plus one I'm taking so here, okay. And next. So zero row is fixed. So for columns we are taking, or else I'll take J so that you can clearly understood. Okay, this loop we are taking. So for columns here, guys, different knapsack capacities we taken in the columns only, right? So from whenever it's matches zeroth weights of zeroth position, so value matches in the columns loop. Okay, from there onwards we are going to start filling here. Okay, uh, it may be so weights of zero, it may be four or else five. From there onwards, we are going to fill so the values of zero position value. Okay, in that zero row, that is the base condition conversion here. Should be careful. First of all, we should focus on how to make conversion of base condition. In previous programs, also you observed the same. Okay, so fine. Next. So now we can remove this entire part because this entire part we converted now, okay, into these two lines. If we are at so zeroth index, okay, zeroth row, okay, and so how we return so the values here, okay, so the same values I filled here, and if not zero values already filled initially, right? Okay, it's not required to separately fill now. Now we can remove all these four lines, okay. So fine. So now let us take so the rows loop and next of all columns loop for I in range of, you can start directly from one first row because already zeroth row we filled it, right? Okay. So next, so columns loop. So we need to take from the beginning here. Okay. Up to the knapsack capacity plus one, we need to check. Next, what is the next step? We should take so the entire code within inside of this, inside of for loop object, and doing the same. And now let us start. So working on it. What I said. we should remove so the function call. In place of that we should take so the dp array, right? Okay, I'm removing values, weights, arguments and function call, all this. Okay, in place of that I'm taking dp of I minus 1. Observe carefully, different knapsack capacities, different knapsack capacities we are getting into j variable, right? Okay, so here W means it's fixed. Okay. So with different knapsack capacities, we need to fill, right? Wherever you are going to observe, so the knapsack, okay, knapsack capacity variable W, in place of that, you need to take so the J. Remember this. Okay. This is the point you need to remember, and you need to make change. What I said, in place of knapsack capacity, we need to take so J. Okay. And so here I am removing function call and I am taking so the DP, simple, easily can convert it. Okay, now observe how easily we are finishing it. Okay, next, in place of knapsack capacity we should take so the Z. That's it, completed, guys. Okay, now in place of return keyword, what I said, we should take so the DP of IJ here. Okay, so already said in the beginning program. Okay, and 9, finally after completion of so the both the loops we need to return so the dp of. Okay, so here finally result is going to be stored in the, see here we are taking row values as 0 1 2 3 only. So in size minus 1 and so in knapsack capacity w. Okay, we are going to store, we are going to get the result. So n minus 1 and next of all, so the w value we need to return. Okay, in this last position, we are going to get the result. So now let us run and check whether we are getting so the TL error or not. Okay, observe everyone. Yes, all test cases so passed. And so let us submit now. Yeah, now all test cases so gets passed. Okay, so observe here. I hope so you understood. Uh, check for 2 minutes, everyone. So fine, it's not possible to so explain. So the another program, so coin change. Okay. So the next session, so I'll complete it. Okay. Along with that, so I'll finish. So backtracking programs also, few backtracking, one or two backtracking programs. Okay. Uh, and so gone through the so programs based on so this model, guys. Okay. Uh, so that's it for today's session. Okay. Let us meet in the next session. Okay. So thank you, everyone.